So let's start our today's webinar of the program. So we decided to divide it into two parts. During the first one, I will talk to you about some modern tasks of computer vision in my research and research of my group at HSC University. So my name is Andrey Savchenko, and I'm an academic supervisor of this Master of Computer Vision program. And after that, we have another part in which we will share you some key facts about our master degree, our master program, and how to apply, and so on and so forth. So these are two different parts, and let me start from the first one. So today I will tell you about some recent research of my lab in HSC University. So I divided this part of my presentation into 5 parts. First, I will start with some brief introduction of computer vision tasks. I will focus only on two-dimensional image processing. So there is a huge gap of other tasks in three-dimensional. In 3D case, so I don't cover it today because it's another topic, so it needs much more time for everyone. So this is this part, and you can see that in chat you can ask the questions, but for sure I can't answer them right now, but I will try to answer them if I can after I finish my talk during the second part, when our manager Alina will guide you through our master degree and through our submission process and so on. Yeah. So this is our presentation. So first of all, let me start just with for beginners who didn't know what does computer vision mean and what tasks can be covered during our master degree. So there are plenty of tasks. I will just introduce you some of them that are the most popular, so that I hope you can try to guide. You can take a look and you can understand what I will cover during the introduction of research of my group. So the first and the most important one is so-called image recognition. Image recognition, the task of image recognition, you have an image, you have an object on this image, and you want to classify it, to set some label for this object of the image. You assume that there is only one object, or if there are several objects, then it's not assumed that the image recognition technique should work correctly. Yep, and so here are some examples, so you have this object, and the output of image recognition will be the class, something like Siberian Husky, or Eskimo dog, or cat, or I don't know, some face of some guy, for example, in face recognition task. Yep, and we will cover face recognition in the remaining part of this talk. And here is some example of the output of Wolfram image identifier, so which solve the service which try to solve the image recognition task. You see that there is some of my photos, but the output class is Bastion. So there is a Kremlin, and there is no class like person or face in this service. So they try to find some object which it knows, and it finds this Kremlin or Bastion. This is the most important problem probably in the whole computer vision. But in general, there are plenty of methods that can solve it. And for sure, in our master degree, we will try to guide you how to solve real applications of image recognition. Another very important problem is so-called object detection. So you have plenty of objects. It's assumed that you may have many objects on your photo, on your image, and you try to find the positions of these objects and also the classes, types, or labels of this object. So you see that there are something like dog, person, chair, another chair. So you need to find so-called bounding box of the object, something like this, rectangle around the object. this task is much more complex when compared to image recognition, because actually image recognition is in some cases it's a special case of object detection task. So you need to find not only the class of the object but also the position of this object, and you assume that there are many objects on the same photo like this. Even the more difficult task is so-called semantic segmentation, in which you need to you still need to find the objects with, but in this task you will you need not only the to find the bounded box of the object, yeah, something like this is the person, but you need to find you need to find all pixels of each object. So you see that there are some pixels like cow, grass, something like this. So for sure, it's rather difficult task. So you see, for example, the body, but body without head, yeah, something like this. So and the pixels corresponding to the head of this woman is in this particular case, it's a mistake of semantic segmentation. It's really difficult task. So this face of this woman is considered as a tree. Yeah, you see something like this. So this task is more difficult because you need to assign each pixel to the label and need to be sure that the close pixels correspond to the same label. You need to find borders, exact borders of objects, and so on and so forth. So here is just a nice figure, well known, how to distinguish these types of tasks. You see that this is a classification. You just output the cat. This is classification and localization. Localization, it's a part of detection task, but in detection, it's assumed that you have many classes, but here you see that you have only one object, so you need to find the position of this object and to classify it. Yeah, this is the object detection I showed previously, and this is instant segmentation when you need to find exact borders of objects, and also the pixels inside this borders are considered to be the some classes like cat, dogs, and so on and so forth. Yeah, so these are the most important. These are the most important tasks, and many computer vision technologies are based on solving these tasks. Usually object detection or classification. These are two the main one, but in many cases, like in autonomous vehicles, instant segmentation is also very important. So, but there are plenty of new, more interesting modern tasks which are usually solved. So one of them is so-called image captioning. You have an input image, and you need to provide to output the text that describes this image. So something like this. So you see the algorithm obtains, so the input of the algorithm is this image. And the desired output is something like this: a person riding a motorcycle on a dirt road. Yeah, and so on and so forth. So it's really difficult because you need some kind of knowledge here. Yeah, some basic knowledge, common sense. You need to understand that these are the objects, their locations, positions. So it's not it's not a pure object detection, for example. Yeah, for sure you need some kind of object detection like skateboarder, some tree, cramp, dog, yeah, frisbee, and so on and so forth. But still, you need to create a textual description. Yeah, and it's a really important task in many applications right now. There is some well-known tricks which we'll definitely cover in our course on mobile devices and during our master degree. This so-called style transfer. When you have some photo, for example, yeah, so input photo, and you apply some style from the, I don't know, from Van Gogh, for example, yeah, you have, again, input image, and you apply the style. You try to create the picture or the art which has the style of some famous artist, but that displays your photograph. So something like this. So it's really easy right now because there are plenty of really nice models that work, and even you don't need to. You can apply any style for any, so you can upload the input image and any picture, and you can mix them, and there are really nice capabilities in doing this work. So there are some other tasks, something like recognition of painting. And what is really interesting here that most of these tasks can be solved really easily if you have plenty of data. This is the most important in our in computer vision. You need data. You need data, and probably in most cases you need labeled data. So you need to label the data, and actually during the engineering process, the labeling of the data. I mean, you have a large data set and you need to locate the objects on this data set or something like this. So actually, it's one of the most difficult, one of the most time-consuming part in creating the computer vision software. And again, we have some kind of courses that cover the problems of software development for computer vision. So these are the tasks for recognition of paintings. Then when the user paints something, and the service computer vision algorithm try to understand what does it paint. So you see that this is a sketch. So first of all, user started with this one, and it's recognized a rainbow. After that, this line, and this is similar to tree. Something like mountains, apples, and so on and so forth. So really nice capabilities. Some other, probably not well-known tasks, but I believe it's really interesting. It's so-called predicting image memorability. So you have an input image, and you try to understand if someone can remember this image. I mean, the object on this image, or this is something so some photo which you can't remember. So you don't need actually to make this photo if you can't remember it. Yeah, something like this. So these are non-typical tasks, but still they are really nice. So let me move to the main part of today's presentation, and I will guide you through several projects together with my students from our offline bachelor and master programs. Yeah, so and the first one is the project funded by Samsung. So it's devoted to so-called user preference prediction on visual data. Here there are some papers which we published with my students, with my PhD students, and I hope we can do the same even with our new students of our master degree. Yeah, so in journals like well-established journals like pattern recognition, conferences, patents, and so on and so forth. So what is the task about? You have, so many of us have mobile phones, and many of us enjoy taking photos using these phones. So that's why, as a result, you have a great amount, you usually have a great amount of photos on your device. And probably they, in some cases, they reflect your interests. Because if you enjoy football, you will take photos of football match or some sport competition or something like this. If you like me, enjoy visiting on some conferences, especially offline conferences, then probably you make photos of these events, and in this case you will have plenty of photos of some lectures, museums, some food. So in this case, if the mobile device can analyze your interests, your preferences, just based only on your photos on this device, you can create something really good recommended system. For example, when you travel to the new city, you want to visit a restaurant. What's a good restaurant for you? So it's easy to analyze your photos on your mobile phone, and if you make some photos of food, yeah, it's easy to find the type of cuisine you prefer. So probably you prefer pizza, or Italian food, or sushi, or something like this. Yeah. So this is the task: is to gather the user's profile, the user's interests, just based on analysis of his photos, without any text, without anything else. For sure, you can analyze the profile of a user, but what does your photo can take about you, can say about you, about your interests? Yeah, something like this. So there are so you may be interested in hobbies, in foods, in pets, in your family, something like this. For sure, it's really important if you that the most probably important part in such application is privacy. So you have a lot of photos on your mobile device, and probably you don't want these photos to be sent to some remote server outside of when you don't know how they will use it. Yeah, so you don't want your private photos to be analyzed on remote device. But and so in this case, we have to process the photos on your mobile device. But it's still possible that there are some photos that can be considered as public. So you make a photo in some museum. Yeah, there are no faces, there is some paintings, there are no relatives, your relatives, friends. So this doesn't contain private information. In this case, it's still possible to analyze the photos on the remote server, only these public photos. And one of the tasks here is to classify each photo if it's private one or the public one. So these are some public photos, yeah, something like nature, computers, so I don't know, something like this, and they can be processed on remote server. It's not they must not be processed, but they can. So the user can say that, okay, my public photos, so you can process my public photos on the remote server if you can do it really accurately. And all the private photos should be processed on your device, so you don't want to send your private photos with your face or with the face of your children, for example, to the remote server. So in this case, you need to apply fast, lightweight mobile networks and so on. So this task was solved by our team during the creation of some some neural network that try to classify the public photos and private photos, also try to find selfies and so on. Yeah, but after that, you need to understand the scene, so-called scene recognition. It's a part of image recognition. What's displayed on the image? So is it a football or match, or if this is a museum, or is this is a lecture? So this is classical image recognition problem. I told before that image recognition is one of the most important tasks in this, one of the most important tasks in all computer vision. So there are plenty of techniques how to work with these tasks, and probably we need still a course of deep learning and computer vision to cover these techniques. So I can just tell you that you need some deep convolutional neural network or deep transformer. But if you want to solve this on mobile device, it's still deep convolutional neural network. You can fine tune it. You can tune it on your data set of some scenes or specific events, and something like this. So this is really important task how to solve this image recognition problem, and there are some techniques. And what is interesting that they really works right now. So probably if you visited our previous webinars, I told you that there was a revolution in computer vision 10 years ago. So right after them, you can solve most of image recognition problem if you have enough data. Yeah, okay, there are some other interesting stuff, how to combine object detection and image recognition. And together with my students, we propose some really nice pipeline, how to combine them. So you solve the scene recognition problem, and you also try to detect objects like persons, shoes, tree, and combine the results together in some kind of ensemble to understand the to understand the scene, to understand what's here. And we showed that in several experimental studies that it really works. And there is some kind of pipeline how to apply this such kind of algorithm for a gallery of photos on your mobile device. Let me show you some examples of object detection, because why do we need still to understand if the object if the photo is public or private? So if so this is not public photo, but still this is a good example, I believe, because these so-called very deep solutions for object detection. So you see that it's really accurate. but you can't run it on mobile device. You can run something like this, mobile nets or something like this. So in this case, yeah, you can find something, but you see that it's not enough. And some example of public photo, for example, from I believe Cherbourg. Yeah, you see this is a detector, mobile detector. So it works here. But if we can understand that this photo is public and send it to some remote server, we can find some towers or palm tree plant or something like this. And there are many other examples which prove that it's still better to analyze public photos, at least public photos on the remote server. So there is some kind of mobile application and you can play with it. So it's publicly available and you can run it on your Android device and try to find your preferences, like preferences in indoor, outdoor, your demography, try to predict your demography. So you see, this is an example of my preferences visiting museums. And I mean, it's indoors museums, archive, and something like this, art gallery. Yeah. Okay, this is the demography analysis, and this is my part, so it's me, yeah, and this is my children, yeah, my father and mother. And here are some examples how it processes the photo, how it try to. So you see the scene football, for example, is predicted here, event sport. And also it has some face recognition techniques. So you see that it's recognized me here, yeah, and this is one of my child, but but the age is not correct here. Yeah, and so still we still so it's the problems are still unsolved. So still you have some issues, some problems, and you need to solve them. And that's why the computer vision right now is really developed. It's really development field, and plenty of companies try to hire engineers to solve their problems using modern computer vision techniques, because it doesn't work 100% accurately. Okay, and let me show you some examples how to apply it for real profiles in Instagram. So what profile we can gather by analysis of the photos only. So here is, for example, the Rolling Stones profile. You see that there are some photos, different photos. And if we try to understand the scene, you see that if we analyze the whole profile of this rock band in the Instagram, you see that the top scenes are stage, arena performance, music studio, art gallery, clothing store. I mean, they are rather fashion guys, yeah, and so on and so forth. Yeah, so top scenes are really correlated with the interests of these guys. And the same for object detection, guitar, suite. There are some sport equipment, but it's a rather general class, fashion accessory, and so on and so forth. So again, top objects are really nice, and you see that the red bars here stand for the whole pipeline with analysis of public and private photos. Another examples, the Russian player Savchenko. Yeah, and you see that if we analyze his Instagram, you see that fashion accessories, sport equipment, hockey. Yeah, so again, top scenes correspond to his interest. Fedor Konnikov is a traveler, and you see boats, watercrafts, airplanes, hangars, and so on. Beyonce, again, fashion accessories, sunglasses, dress, stage, performance arena, dressing room. So really, so it's just pure analysis of their photos. Some other example, Gordon Ramsay is a famous chef. Yeah, food, pizza, fashion, fast food, sweet, restaurant, bakery shop. Disneyland, so we can analyze the photos of not of person, but of some companies, yeah, and again, some toys, castles, something like this. Famous artist, picture frame, sculpture, art gallery. LeBron James, again, basketball player, so basketball, arena performance, and Kim Kardashian, fashion accessory, dress, swimwear, sunglasses, high heels, discotheque, and so on and so forth. Okay, let me move to another part. So it's another project devoted to facial processing and trying to understand emotions of people, of a group of people. And again, several papers with my students, with my PhD students. And probably you can join to our team if you will join our master degree. So there are plenty, again, if we speak about processing of facial images, there are plenty of different tasks here. The first one is detection of face. So face detection is just detect the faces. It's a part of object detection task. Verification, if it's another task when you have two photos and you try to understand if it's the same photo, the photos of the same person, or these are the photos of different person. So when you use, for example, the your mobile device and you try to predict by using this mobile device just to open it by your face, you solve the face verification problem. The algorithm on your mobile device solve this face verification, but using videos. Face identification or face recognition is something like this. So you have input photo, you input video, and you have several classes, and you need to make a decision what is the subject on this class. And in some cases, it's really difficult if the faces are gathered in the web. Yep, and some tasks like recognition of attributes of faces, emotions, age, gender, race, something like this. So yeah, you see. Okay, and so what particular task we solve in our project? We are interested in emotion analysis. So actually, we obtain the models, deep neural networks that show the state-of-the-art results in several tasks in emotion analysis. Okay, so what we are interested about, we need to analyze the photos or the videos of some guys and try to predict some emotions and the changes of the emotions. Also, what's interesting for us is to analyze the videos of students, of speakers during online conferences, online lectures, something like predict engagement of students. So if this topic is interest for someone or not, and if it's possible to analyze the face, so its face is not a black box, then something like this from our conference at HEC University, then it's still possible to find the moments in which most of the listeners were happy, for example, or most of the listeners were disentangled, so the topic is not interesting for them, and they try to move the eyes outside. So there are some typical tasks here, like video-based face emotion recognition. So you have a short video of some, so this is movies, and you try to predict some emotions like classes like happy, sad, surprise, and so on. There are more interesting and more difficult tasks which we also solve during this project. It's so-called group level emotion prediction. So you have a group of people and you try to understand the emotion of the majority of people in this group. Yeah, something like this. There are three. So it's not even the emotion; it's like an affect. Yeah, so positive, negative, neutral, something like this. So these are publicly available data sets, and we prove that our models work better than anyone else in this tasks. And this is about engagement prediction. Again, you see the engagement level of students listening to online course. And this is really important for our master degree, because we are online master degree. So we definitely want our students to be highly engaged in the topics of our master degree. So how to solve it? Again, there are some really nice techniques how to solve the face recognition problems, and they're slightly different when compared to the image recognition, because there are plenty of data sets of celebrities, and you can train your neural network, and after that you can use it as a feature selection. But you cannot. It's not assumed that you can gather a large data set of faces you want to, for example, recognize. So if you want to create a smart house and to try to recognize your family members, you can gather and label several photos, but it's not assumed that you will gather 1,000 photos for each family member. Yeah, so it's usually impossible. So you have some small training sample, but still this approach is really work. And we applied these approaches to those. So we trained the neural networks that try to predict emotions, and after that we applied to analysis of video conferences and extract the some parts which are the most interesting for the group of people. Yeah, something like this. So you see the conference, some of our partners at school. So some online school, and you see you will detect the faces, you group them, and after that you predict the emotions of individual faces here and also the group level emotions, and it really works. And I hope it will be implemented in some by these guys who are the who asked us to develop such kind of techniques. Yeah, and again, this is implemented in the some applications when you can load your photo and you find the you will find the emotions of faces. Also, you will find some like something like something like age of these faces, race, and so forth. So this is the part of the mobile application I showed you previously. So we implemented it also here. Okay, let me move to another part. It's I have two additional parts, but they are really, really small. So first of all, it's food classification and restaurant recommendation. It's actually it's a part of this large project with Samsung, which we wanted to first analyze the preferences of some of a user or mobile phone, and after that we needed to develop some kind of recommended engine for traveling. And in these papers and in this part of this project, we try to understand the most preferable type of cuisine of a user, and we try to predict what is the most interesting restaurants for him or for he or she. Yeah. So this is the part which is actually, I hope if you're with me still right now, this is the part that uses practically the same. So it solves several computer vision tasks. So you need to detect food. This is the part related to object detection. You need first of all, you need to recognize scene. So is it a photo of food, of restaurant, or this is a sport competition, so you don't need to analyze the type of cuisine during the sports competition or some museum or something like this. So if this is a restaurant or cafe or some food is found, then you need to detect food in this photo. And after that, you need to classify the type of cuisine of this food. So if this is Chinese, Japanese, Russian food, or something like this. Yeah, and you will detect it, you will recognize it. So this actually 3 computer vision tasks are solved here. First of all is scene recognition. So this is a photo of restaurant or cafe or something else. Then you detect food, and after this food detection, you try to predict, again, recognize the type of cuisine of this predicted food. Why do we need the first stage? Because object detection is really slow. So we can easily filter most of the photos without needing to run object detection on your mobile device. Yeah, and something like this. Yeah, some other example here. And what we did, so we created some servers which can be in which you can upload your Instagram account or just a single photo. It will predict the scenes, the food detected on it, yeah, type of food. And actually, what's really important, we can recommend the restaurant based on your preferences. So this is for single photo. You see there's something like Chinese food, yeah, Chinese, Japanese, and here are the top restaurants recommended is in Las Vegas. So you can choose the city, and so you move to Las Vegas, and this is the photo on your device, and you have plenty of photos with Chinese food. Then you see that the engine will recommend you Chinese or Japanese restaurants with top stars. So it chooses the top restaurants near you, probably in the city, yeah, which are interested for you. So this was a part of the large Samsung project, and it worked really nice. So you can gather your profile and you can use it for recommended restaurants. And probably the last part here, I mean, the last task I wanted to show you is so-called understanding advertisement. So it's absolutely different, but it's again some part related with my colleagues, with some of the also my former students here, and I just show you how different can be the task which we solve during our research. So this is so-called automatic understanding. So you have, we assume that there is a video or some image of advertisement. And we need to predict the topics of this advertisement, the sentiment, and some symbols. Symbols. I will show you symbols in the next slide. So you see that this is the advertisement and its length, and you see that there is something broken here. So this is anti-deforestation and advertisement. It's really difficult to analyze such kind of images because you need some common sense. So you see that this is a forest, but still it's a symbol. So this is a forest, but still it's a symbol of lungs. So you see that this part is broken, and you see that there are some problems here. So it's deforestation, and the topic is environment, for example. You need to predict the topic, you need to predict the symbolism, and so on. So some other examples here for audio cars, yeah, and again, it's in some cases it's not obvious what's the symbol, what's the topic that it is. So in some so the topic is probably easy to find, but still it's in a single photo, it's not so easy to detect car based on even contemporary object detection techniques. So you see a silhouette of car, but still it's not easy to detect it. Yeah, but our image analysis techniques which was developed during this project, can analyze them and can predict these topics, sentiments, symbols. The symbolism is really important in the advertisement. So you see some examples from this data set, yes, something like strength. So you see line, you see strength, and you can understand that this is the hair. So this is not real. Yeah, you need some common sense that line is strong. Yeah. This is something like this: spicy alcohol destruction. You see that fire here, alcohol, fire, yeah, sorry, yeah, something like this. So again, tequila, and disclaimers, and danger resident, the symbols here. So our task was to find the symbolism in image analysis, and we developed some really nice multimodal technique based on one of the parts here was so-called optical character recognition. This task hasn't been covered by me before, but so in some, it's assumed that in many cases it's solved, but if you understand, if you try to feed the photos of the images of advertisements, for example, you will find that even modern optical character recognition techniques don't work really well. So here is some analysis of techniques from my students, or I don't know, something like this, and you see that there is some good results. So for sure the results of Google services, but still, if you use some kind of publicly available services, they don't work really well. So we definitely needed to improve the quality of this optical character recognition. Yeah, and for in the wild photo, this is not even the photos. Yeah, you see, this is the advertisement. This is some videos how to recognize image, how to recognize text in these images with different font, with different size of symbols. So it's still even one of the most simple tasks in computer vision is still not so easy to solve. So we will show you how to do it. And here is some example of how we solved it. It was some really nice pipeline with multimodal processing of this. So this was the part related to image recognition. This was the part related to optical character recognition. After that, you obtain the text, and then you can analyze the text using natural language processing techniques. So this is very typical right now in many multimodal systems to combine text and and images, yeah, and here we obtain text from image. So you see computer vision here, just a pure image recognition task, and here just a task to prepare text for natural language processing techniques. And we use something similar in analyzing of videos, but in videos we recognize speech. So we recognize speech, convert it into text, and then process this text together, for sure, together with analysis of visual content, together with optical character recognition, and again, it's really well. So yeah, this is some pipeline with some combination. Again, what I wanted to show you that there are some Lego parts, some simple tasks of computer vision. And if you try to solve some real tasks, even in research, you need to combine these Lego blocks into a single solution. Yeah, you see that image-based prediction, object detection, optical character recognition, text analysis. So you combine all of them together to obtain the result which is appropriate for customer or for your company or for someone who wanted you to solve this task. Yep. So I believe this is the end of my today's presentation. I will try to answer your questions if they have, and at the same time, I believe Alina can share a presentation of our master degree.
Yes, I'm here. Thank you for such a saturated presentation. I sent 2 questions. I accumulated and sent in common chat 2 questions. Please check them before I start my part. Do you see this question? Andrey, this is questions for you. Do you hear me? Or not?
I will answer some questions in the chat.
Oh, okay. So let me.
Yeah, I believe it will be better. So yeah.
Okay, wait a second. I'm going to share my screen.
Go ahead.
Oh, let me check. Do you see my presentation? Hello, do you see my presentation? Somebody please tell me yes or not.
Yeah, we can see.
Yeah. Okay. Now we are going to quickly talk about the MCV program. I say quickly because previously we have already organized admission webinar where we discussed and described in details all peculiarities of our program, and you are always welcome to find out the recorded webinars on our official website, or please share your questions in Q&A form or in chat and we are going to answer. So Master of Computer Vision program is completely online from the process of admission to the final exams to get your degree. We organize 1 admission per year and the closest cohort will start this September 2022. During this course, you will complete 16, during this program, you will complete 16 courses and you will also have 2 courses in parallel. By the end of this program, you will build your portfolio with 16 solved CV problems and projects. And our program is supported by 6 industrial partners. And thanks to them, actually, we provide our students with case study. So you practice all skills on real cases from these IT companies. We welcome everyone who wants to study computer vision. However, you must first have some bachelor or master degree. Actually, it is the common rule for all master's program at our university that to apply to master program, please first have bachelor or master. And also we expect that you have enough mathematics and programming experience because our program teaches you at the advanced level. So our program isn't for the beginners. Please take this moment into account. What you will study? You will study foundations of computer vision algorithms, modern technologies of artificial intelligence and image processing. You will have a lot of practical cases with deep learning framework, and you will study development of software with computer vision capabilities. And if you need more detailed consultation about what you will study, please don't hesitate to ask today in Q&A forum or send your requests through the messengers to me or through official email, and our academic supervisor and I will also ready to consult you more deeply, maybe even in Zoom meeting or by email, by messengers. By the completing our degree, you will have enough skills and enough experience to apply for this list of positions connected with computer vision. A short information about program structure. As I have already said, program runs for 2 years on Coursera platform. You will have 8 courses per year. You will have pre-recorded lectures and screencasts on Coursera. And actually this format is very, very comfortable to allow you to combine your study with your general life obligations, because you may study at a comfortable time. Also, we provide for you live meetings with your group mates and with your tutor. The current cohort started in the last year has about one live meeting every 2 weeks with group mates, with tutor. Then they discuss questions, then they get more additional information about the course topics. And also on request, every week you may call and you may call for personal meeting with your current tutor to ask detailed questions. We expect that our students spend about 25 hours per week to watch the videos and to do the tasks. So how we do control your success? Every course has graded quizzes and programming assignment, ungraded quizzes, staff graded assignments, and of course final course assignment, which is controlled by your course tutor. Structure of the program: you will have 2 years of study, 8 courses per year. You may see that these courses have different colors. Blue colors mean programming courses. Green color is the basic course about mathematics at the beginning of your study. Gray color is for professional courses with professional computer vision skills, with master your professional computer vision skills. And orange courses are completely project courses. Then you don't master particular skills, but you execute and do the big project from IT partners of our program. What about the price? We provide a discount. Unfortunately, we don't provide any scholarship, but provide up to 50% discount. Price without discount is about $12,500, and we allow you to divide this price into 6 payments during 2 years. Please take into account that this is price before discount, and which discount you may apply for, you may find on our website, and the amount of discount depends on the country of your permanent residence. For example, for people who currently live in India, may apply for 20% discount. People live in different country may apply for different number of discount. Please check our website to check the price for you. And how to apply? There are just 3 simple steps. First one is registration. At the current moment, foreign citizens could register in our system and choose our program. For Russian applicants, registration will open from the 1st of April. So first you register, it is for free, you shouldn't pay for registration and entrance exam. Second step is actually entrance exam. This year we will organize 4 sessions of entrance exam, and you may take part only once. So please, after registration, choose the appropriate exam time. And after successfully passing entrance exam, you need to pay and sign the educational documents. So you register after pass entrance exam, after you decide if you will start studying or not, and after you execute first payment. First payment must be done before August 20th, and the minimum sum which we expect from you is about $1,664. This price is under discount. For the future information, please visit our official website. I have have said about it several times. Just search on the internet HCE Master of Computer Vision, and the first page will be our official website. It will look like this. And speaking about upcoming events, first exam session will take place on March 31st, and those who have already registered for it, for you, we organize how to prepare for the entrance exam webinar. And actually, we welcome everyone who are interested in exam preparation. On our website, you may find exam paper number 4 without solution. You may do it, practice, and on the webinar, check your results, check your answers, and find the common mistakes which our applicants usually do. Yeah, and context. I'm always welcome you in messengers. To my mind, it is the most quickly and appropriate way to communicate at the stage of admission campaign, because I quickly react on any requests and answer to you, and maybe sometimes academic supervisors also joins these messengers. So you are welcome now to ask your questions by voice or in Q&A form, probably. Super cool projects. I'm reading the Q&A form. Super cool projects from Dmitry Grau. Yes, thank you. Thank you to Andrey, our academic supervisor. How much is the cost? As I have already said, before discount, it's about 14,000. Yeah, wait a second. 12,500. This is before discount. After discount, if you apply for 20%, it's about $9,700. That's with discount 20%, but you must check your country. This is for
I can answer. Yeah, I can answer the last questions in the Q&A form. Actually, there are 3 questions there. So first of all, will we study GAN networks? GAN is generation of adversarial networks. Yeah, we have a course, a whole course of generative models, and the GAN is the most important part of this course. So we will definitely, you will definitely study GANs. Yeah, how to work without GANs right now and today, because actually it's one of the most important parts in generative computer vision. So today I spoke only about understanding images, but yeah, there is still a large part of computer vision which try to generate images, and GANs are one of them. So we will cover it. Okay, how deep will we go into the pure math? So it's actually it's rather rather difficult to answer this question, because as I understand, there is no single question on this, a single answer on this question. So we have some adaptation course, and during so we have adaptation course in mathematics for computer vision. So this is adaptation for someone who is not very familiar with linear algebra, something like this. Yeah, so these topics are really important, and you will try to adapt. So this is an adaptation course. And in other courses are mainly focused on solving some practical tasks. But practically all of them contain something related to if you don't understand deeply the mathematics and the whole, you cannot, in many cases, you can solve some computer vision problems. So we try to to explain something about mathematical part related to some computer vision algorithm, but we still think that so our master program is not about pure math. So it's not a theoretical mathematics, and there are some another problems. So we want our students to solve practical tasks in computer vision after the end of our master degree. when our instructors, lecturers understand that, so when see that the students need to understand something deep from mathematical point of view, yeah, they definitely provide you some kind of this knowledge, and probably they add some references for everyone who is mostly interested in doing something. And you can ask your questions to the instructors during our webinars with this course, so you can explain so they can explain something to you. So yeah, this is about the second question. And the third question: how do we use C++? Actually, we have several courses. So during the previous webinar, I told that there are two parts of computer vision in the history. There is so-called traditional computer vision and deep learning technique. So when deep learning is right now mainly based on Python, but it's mainly it's not the only one language, but it's so mainly Python. But traditional techniques are sometimes used in other languages. So let me just tell you about one of my experience. I have several projects with Huawei company, and they wanted to analyze the images, high resolution scanned images of mobile devices to find some Moore defects, some defects on their screen. So this is really high resolution images, and there are plenty of such images because there are several images for each device from Huawei, for each new device from Huawei, and you need to solve it as fast as possible. So in this particular project, we needed to use C++, to use OpenCV library, because it's impossible to solve it with pure Python. It was too slow. Yeah, so that's why, and actually, from my experience, I observed several projects which needed, which better worked and which better needed C++ or something like this. So in this particular case, Python doesn't work really well. And we also have, so I answered it in the chat, that we have a course related to mobile processing, mobile devices, and mobile devices. So if you want to develop application on mobile devices, you need to choose usually between Java, Kotlin, and part of C++, because it's possible to use native C++ calls in your Android device. So it's no Python, no Python at all. And so if you want to do something what I show you today, yeah, you need something like C++, Java, or something like this. So it's impossible to use Python in mobile devices. So yeah, and that's why we try to cover these topics, so you can apply computer vision not in theoretical part in some Jupyter notebook, but you can solve really practical tasks from industry. I hope this election will be use. Actually, yeah, as far as so there is some adaptation of our. So there's still some courses are under development. I mean the courses for the second year, and as far as I know, most of our instructors prefer Python, because when they show their results, yeah, they will when they show some ideas, the Python is much more appropriate. But again, yeah, it's still possible to use C++ with something like TensorFlow Lite or something like this, so you still can do it. But again, if you want to speak about training of deep neural networks, then Python is enough for you, because you don't want to distribute the training script to some customers. Yeah, but if you create some application, yeah, you can still need to use, in some cases, Java, C++, Kotlin, Python, anything else. So we will partially cover these topics. Yeah. Okay. Okay. I hope I answer your questions. Actually, Alina, I didn't see any other questions in the chat and the Q&A form.
Very, very wide answers from you and information. I think everything is very, very clear. So I think we can stop today's webinar. As usual, everyone may find the recording 2 days after, for example, in 2 days, yes, on our official website in section webinars. You're welcome. And also, could we share your presentation on our website?
My presentation, yeah, I will send it to you. So it's it's not a secret.
Amazing.
Yeah.
Okay.
Yeah, no problem. So thanks everyone. If no one have any question, then thank you for visiting, and I hope you will join our next webinar and join our program.
Yes, and welcome to share your questions in messengers and via official email. You also may find it on our website. And also Abraham Buffer shared his email. What is the purpose for? I will save your email, dear Abraham, and send you a message like, this is Alina, what are you interested in and for? Yeah, let's stop the webinar, stop the recording, and stop.
Yeah, goodbye, everyone.
Goodbye, everyone. Thank you for attending. Save the email. Yeah, dear Abraham, I saved your email and I'll contact you tomorrow.